Good evening, madam. My name is K. Rahul. I am from CSCB BS section, and my roll number is 234G18056, and the subject is data logics and computer organization, and my topic is about half adder and full adder. Half adder and full adder. Half adder and full adder are fundamental building block in digital electronics. Their circuits perform binary addition, essential for arithmetic operations in computer. Understanding their functionality is crucial for grasping more complex digital systems. Introduction to binary addition. Binary system. Binary system is the foundation of digital computing. It is uses only two digits. They are 0 and 1. And binary addition. Uh, addi Adding binary numbers follows similar rules to decimal addition. Carry over occur when adding 1 plus 1. Digital circuits. Adder circuits perform binary addition in computers. They process the bit to produce sum and carry overs. The need of adders. Arithmetic operations. Adders are crucial for performing basic arithmetic in digital system. They enable complex calculation in computers. Digital processing. Adder process binary data swiftly. They handle large amount of information in microseconds. System integration. Adder is integrated into large circuits. They are for more complex arithmetic units. So the half adder concept. Two inputs. A half adder adds two single binary digits. It processes two one bit numbers. Two outputs. Uh, It produces a sum and a carry bit. The sum is a result of XOR gate operation. Limitations. Half adder can process carry in the previous addition. This limits their use of multi-bit addition. So if we give one input, they will give two outputs. The half adder circuit XOR gate. XOR gate generates the sum output. It is true if inputs are different. And AND gate. So it produces the carry output. It is if it's true when both inputs are one. And circuit integration. XOR and AND gates work together to create the half adder functionality. So the half adder functionality is created by XOR gate and AND gate. And half adder truth table and outputs. If they are input A and input B and sum and carry. If the input A and B are 0, then the sum is 0 and carry is also 0. If the inputs are 0 and 1, input A is 0 and input B is 1, the sum is 1 and the carry is 0. If the input A is 1 and input B is 0 and the sum is 1, then the carry is 0. If both the inputs are 1, then the sum is 0 and the carry is 1. It performs sum if 0 plus 0 equals to 0 and 0 plus 1 equals to 1 and 1 plus 0 equals to 1, and if both inputs are 1, then it becomes 0 and carry become 1 when both inputs are 1. The full adder concept. The full adder performs it has three inputs. Full adder process the binary digits. They handle two input bits and carry in bit. Two outputs. They generate a sum and a carry out. This allows for case cascading and multi-bit addition. Versatility. Full adder can be used for both single bit and multi-bit addition operations. The full ladder circuit. The full ladder circuit is in the form of if inputs in it in input say three inputs enter the circuit A, B. and carry in logic gates. XOR and OR gates process the inputs. They generate intermediate results. Output storage. Final sum and carry, they can be used in calculations. Full adder truth tables and outputs. They have three inputs. They are A and B and C in, and it has two outputs, sum and count. If A and B and C in is 0, then the sum becomes 0 and count becomes 0. If A and B are 0 and C in is 1, then the sum becomes 1 and C out is 0. And if A is 0, B is 1 and C is 0, then the sum becomes 1 and count becomes 0. If A is 0 and B is 1 and C is 1, then sum becomes 0 and count becomes 1. C out become 1. If A is 1 and B is 0 and C is 1, sum is 0 and count C out become 1. If A is 1 and B is 0, B is 1 and C is 0, then the sum becomes 0 and count become 1. If A is 1 and B is 1 and C is 1, then the sum become 1 and count become 1. Comparison of half adder and full adder. Half adder. Two inputs, simpler design, limited to single bit addition without any carry. Full adder. Three inputs, more complex, can handle the carry in suitable or multi-bit addition. Usage. Half adder for basic operation is full of adders for advanced arithmetic in ALU. Thank you, madam.